So far, what we have done is we have used some kind of a retrieval model that uses a keyword matching mechanism. Based on that, we have made some retrieval model which scores a document for a given query in some way or the other, similar to this way, similar to this very basic function, and then we score the document based on this. And while doing this, we have discussed this is basically can be considered as the term weight, and we have discussed different ways of setting these terms based on different mechanism. For example, we have discussed language model with Dirichlet smoothing, where the term weight is set based on this, or say BM25 similarity, where the term weight is something like this. And based on this, we perform the retrieval. We select a set of documents, we score a set of selected documents, and then we return the set of documents after sorting them based on their scores, right? Now, in the first part of this course, we started with indexing. Then in the second part, we basically discussed this discussed this retrieval using the index that we have made in the first phase. We retrieve a set of documents for a given query, and the retrieval model returns a set of documents. And this set of documents are returned back to the user as the result, and the user basically evaluates how good the result is. So for a given query, how good the result is evaluated by the same user. So in this part of the course, we will be focusing on the evaluation, how we can evaluate the performance of a retrieval model. Now, let's motivate ourselves regarding the comparison of the performance of various retrieval models. Let's say we are given a set of numbers and we need to sort them. Let's say we have used, let's say we are, me and one of my friend is basically writing different codes. My friend has written a heap sort and I have written a bubble sort. Okay. So the task is given a set of unsorted terms or unsorted numbers, we need to sort them. So which is better, heap sort or bubble sort? So any clue, any answer, anything that you can say? Which is better, bubble sort or heap sort?
Heap sort.
So you are saying that heap sort is better than extremely sorry. Heap sort is better than bubble sort. Why?
The time complexity in case of heap sort is lesser than the
Correct. Can you say what is the time complexity of heap sort?
n log n.
And what is the time
Bubble
complexity
sort
of
n square?
n square? Absolutely correct. Complexity. So based on the time complexity for heap sort, it is order of n log n. for bubble sort, it is order of n square. So as order of n square is greater than order of n log n, so heap sort is better than bubble sort. But if we look at the result, can we compare them? This is producing a result, it is producing another result. So it is producing result 1, it is producing result 2. Can we compare them? Come on.
No, result in case of the two sorting, the result will be same.
Correct. So the result will be same. Not actually equivalent, it will be same. And result will be exactly same. But this will be taking higher time than this. As a result, as a result, the result production will be taking some time for bubble sort as compared to heap sort, but the ultimate result will be the same. Now let's consider our searching scenario. Let's say we have 3 retrieval models. Let's say we have Google, we have Bing, we have DuckDuckGo. Okay. Now let's say Google is using BM25, Bing is using language model, and DuckDuckGo is using DFR. It is a really a another retrieval model which is called divergence from randomness, which we will not be discussing in this course, but it is a very good retrieval model. So let's say these are the 3 retrieval models that we want to compare. How can we compare them? So of course, the number 1 factor is time complexity. So time complexity, that is who is taking less time, is better. Considering that all of them are taking similar time, the most important in this case is basically the result evaluation or result quality. Considering that the time complexity are equivalent for all the retrieval models, result quality is basically used to understand the performance of a retrieval model. So considering the WWW or World Wide Web, given a query Q, we can assume that the individual retrieval models will be producing different retrieval results, right? Because the way they are designed, they are quite different. And of course, World Wide Web is huge. So given a query, it is highly likely that they will be producing different retrieval results. This R1, R2, and R3 will be quite different from each other. This we can assume. So the way we will be comparing the retrieval model, or the way we will be comparing the performance of the retrieval model, will be based on these results that they are producing. That is, in short, we will be measuring the quality of the result that they are producing as output. So information retrieval is actually an entirely empirical discipline. Empirical means we need to check the validity of any retrieval model or anything practically with practical data. That's why it is called empirical discipline. It might be the case that in theory, one particular model is, model seems like a very good one, but in practical, it might be failing hugely or failing miserably. For example, the rule-based stemmer. is basically we are handcrafting the rules, for example, the Porter stemmer, where we are saying that if the word is ending with SSES, we will be stripping off the double SS at the end, and something similar for other cases. This is a rule-based stemmer, and we understand that rule-based stemmer can actually fail miserably for certain situations. As compared to that statistical stemmers are actually very complicated ones, where we are writing or where we can actually write certain statistical measure. I mean, we can use certain statistical measure like co-occurrences, based on which we can stem some words, we can unstem some words, we can keep some words as it is, and so on and so forth. Note that these are really sophisticated ones as compared to rule-based stemmer, which are quite simple. So in practice, we may realize or we may understand that rule-based stemmers rule-based stemmers work better than statistical sophisticated stemmings. So that is why it is said that as information retrieval is an empirical discipline, we need to check everything practically to see whether the performance is actually a good one or not. Okay. And of course, we need to validate before, so let's say we developed the retrieval model. Theoretically, it seems awesome, but at the end of the day, when we apply that retrieval model on a certain data set, we are experiencing a very bad performance. It might be the case. So every time we need to validate their performance. So in order to research in information retrieval, a person named Cyril Cleverdon in early 60s made a very nice framework that is called Cranfield Model. So in the Cranfield Model, the benchmark data that we will be given is basically consisting of three parts. Number one, the document collection, that is contains the documents to search on. So you can consider this is a www. Number two is the query. So it is basically the query to search with. This is search on or search inside, and this is to search with. You can consider this as the query that we are submitting into Google. And the third is basically the relevance judgment. That is, for the given query, which documents are relevant and which documents are non-relevant. Basically, that marking. This is the third part, which is called the relevance judgment. Given these three components, we can actually compare or we can actually evaluate the performance of a retrieval model quite easily. A very nice analogy is you can consider the document collection as your syllabus for an exam. The query is basically the question paper. Note that, one thing I missed is basically this is a collection. It will be basically a set of queries. A set of queries to search with. Note that there are multiple queries. As I was saying during the first part of today's discussion, I will be giving you a set of 50 queries. For example, say 50 queries. 50 query. For 50 query, this is a set. So considering the entire search as uh, as the as your exam, the syllabus is basically the document collection, that is inside which the answers are there. The second is the question paper, which is basically containing all the questions, which is basically all the queries, the set of queries. The relevance judgment is basically the correct answer for each of the query, and the correct answer is basically present in this document collection or in the syllabus. Okay, so this is called the famous Cranfield model or Cranfield method. So there are certain basic assumption on Cranfield method. The basic assumption is relevance of the document will be relevance of the document to a query will be objectively discernible. That is, we can actually understand them. There is no there is no pseudo or hidden information that is there. We'll be just considering the content of the document to measure their relevance. Second is all relevant documents in the collection are known. This is a very hard assumption, not always true, but still in this framework, it is considered as true. Third is all relevant documents contribute equally to the performance measure. This will be cleared in maybe tomorrow's class, when we will be actually performing the measurement, when we will be actually measuring the performance. Measuring the performance is something that is, we will be quantifying the performance of a retrieval model by a number. So then it will be clear. And the fourth one is relevance of a document is independent of the relevance of the other document. That is also not practically true, because as we have discussed earlier, I think if there is a duplicate document in the say rank 1 and rank 2, both of them are relevant, let's say. Now, if I read the first rank document, then the second rank document is actually not relevant to me because the content is same, and I have already read the first document. That is, I have already read the second document as well. So in that case, we can directly skip from document 1 to document 3 or the third rank document and continue our exploration in the rank list. But this, although this is a relevant document, this is not actually giving us any new information that we haven't seen yet, because in the rank 1 document we have already seen all the information, and rank 2 is not including any more information in our mind or in our for our knowledge. So this is practically not true, but in this Cranfield paradigm or Cranfield methodology, it is assumed that all the documents are independent from each other in terms of their relevance.